V. Srinivasan, reader in Computer Science and Engineering Department, Annamalai University. I am very happy to meet you all in this nice occasion. I want to share a few important concepts related to network security and cryptography. As we all know, when the technology grows, we are enjoying the benefits of this technological growth. At the same time, problems will also crop up. So we have to face the problems also, but at the same time, we have to find out some measure to tackle these problems, and we have to prevent such problems in future. One such area is the network communications. That is, communication field is now growing in a faster way such that we can communicate with anybody, anywhere in the world, not only by voice communication, but also we are connecting computers together so that we can make use of the resources anywhere in the world. So this is where the computer network comes into picture. When a computer is a standalone computer, the problems will be lesser. That is, suppose if you connect a computer with another computer, and if you want to share the information and if you want to communicate with another computer, naturally there is a problem that comes in between. An intruder can tap that information, or some misuse of information may happen. So in total, there will be a threat to the total network, so that is under consideration. Let us see some of the examples of such security violations that we are encountering in our computer networks. For example, you are sending a file from one computer to another computer, which is a confidential file. Assume that an intruder in between, he can tap that information and he can read that information. This is one such problem. You take another case where you want to send some information to another person which is to be processed immediately. Suppose if the intruder knows that information should be prevented or blocked, he can block that information and he cannot send that information to the other end, so that user A, when he sends an information to user B, that information is blocked by an intruder C. This is to be prevented. There is a case 3. So in this particular case, suppose if you send some information, that information could be modified in the middle, and that information that is originally sent is now sent as a different information which is undesirable. In this particular case, the total information is modified, or a part of the information may be modified. Let us consider case 4. In this particular situation, you will not be sending any information. The intruder will be fabricating a new information and he will be sending that information to the other end. Naturally, the end user may think that it is coming from user A, but it is not really the information which is being sent from user A. It is fabricated by some intruder and it has been sent to the other end. Now, my question is how to identify these problems, prevent these problems, so that we are now discussing that how such security violations have to be detected, what will be the countermeasure. So these are all the topics which I am going to discuss now in this particular session. Let us first start with the first case. So case number 1. So the case number 1, you are sending a confidential message, and that confidential message has to be sent to the other end without any intrusion or without anybody in the middle tapping that information or seeing that information or reading that information. How can we prevent it? One simple answer for this question is, you now send the information in a form which is not readable by or which is not understandable by anybody in between, so that the information could be again converted back to the original information when it goes to the other end. This is what is called encryption, and when it goes to the other end, you can use a decryption algorithm and then you can decrypt the message and then you can get back the original message. This is the solution for the first problem or case number 1. We will consider the first case where you are sending a message from one end. Let us call him as user A, and the message goes to the other end. Let us call him as user B. Intruder wants to read the message. Let us call him as C. Now our intention is to prevent the intruder from reading this message, or our intention is not to reveal the message to the intruder C. The solution for this problem is you convert the original message into a form which is not readable by intruder C, so that when it goes to the other end, again convert the transformed message into the original message. The message from user A is now called as the plain text. When you convert it, it goes to the other end as a ciphertext. Conversion of plain text to ciphertext is known as encryption. When it goes to the other end, the ciphertext has to be converted again to the plain text. So that the ciphertext cannot be read by the intruder C. The plain text is known only to the user A and to the user B. So this process is called encryption decryption process. Now let us take case number 2, interruption. Suppose if anybody in the middle intercepts the message and he blocks the message, how to identify that? Suppose if you send a message from end A to end B, so you should have a mechanism to identify this. Similarly, there is a case 3 where a message is being sent and the message is now in between modified and a new message is being sent to end B. There is a 4th case where you will not be sending any message from A, but intruder he fabricates a message, this is A and this is end B. Some intruder he fabricates his own message and he sends the message as if the message is coming from end A. So these 4 types of security threats have to be handled, and we are now going to see one such security measure which is called encryption and decryption. Now we will see how the message which is being sent from user A is transformed into a form which is not readable or which is not used by an intruder C. When it goes to the user B, again it is converted back and you will get the original message. So this particular concept of converting or transforming the original message into a form which is not usable by the intruder is called encryption. Once it is converted, the plain text is so the original message is now called as plain text. Once it is converted, it is known as ciphertext, and this ciphertext goes to the other end. It has to be again reconverted into original message, that is plain text. So the process of converting this plain text to ciphertext is called encryption. And here there are 2 types of techniques normally which converts this plain text into ciphertext. For example, let us consider a message, network security. This network security has to be transformed into a form which is not readable by any intruder. If suppose this is the case, we have to change it in such a way that this is either rearranged or some other character is replaced for every character in this particular message. So when you replace a character for another character, that is called substitution. when you rearrange the existing characters, that technique is called transposition. For example, here network security, in place of N you replace K, in place of E you replace U, in place of T you replace M, in place of W you replace S, in place of O you replace B, in place of K you replace T. So like that you substitute or you replace a character for another character, and if you send the message it will be K, U, M, S, B, T and so on. So the original information network is not sent directly to the other end, so that if anybody in the middle, if the intruder, if he reads the message, he cannot understand what the message is. Similarly, when it goes to the other end, the user B has to reconvert the message into original message. So that reconversion is taken from a table where you have an equivalent characters which are already replaced. So it is a reversible process where this K is again converted to N, U is again replaced by E, M is replaced by T, S is replaced by W, O is replaced, B is replaced by O and so on. In conventional encryption technique, we have to first input the plain text and the key to the encryption algorithm, where this encryption algorithm converts the plain text into a ciphertext using this key. Our idea is to keep the key secret so that only when the key is available you can decrypt the ciphertext into the original plain text. So this is where the idea works. When a plain text is converted into a ciphertext, and when any intruder reads this ciphertext without knowing the key, the intruder cannot identify what the original message is. Even if he knows the encryption algorithm, if he knows the key, then only the intruder can identify what the original text is. So here the key is kept secret. So this type of algorithm is known as secret key encryption algorithm, where the key which is used for converting plain text to ciphertext, as well as the key which is being used for converting the ciphertext back to plain text, they are same. So this is otherwise called as symmetric key encryption technique, where symmetric key in the sense the key which is being used for encryption as well as for decryption are same. So such algorithms uses the same key for encryption as well as decryption. There is one more technique by which the encryption and decryption process is carried out. That algorithm is called asymmetric key encryption algorithm or asymmetric key cryptography. The second type of crypto system which is being used is known as public key crypto system, where the plain text is encrypted using a public key of any person. For example, Ram. When it is received by Ram at the other end, only Ram can decrypt that message with his private key. That means there are two keys which are being used for public key crypto system. One is known as the public key and another one is known as the private key. The public key is open and the encryption algorithm is also open. Anyone can use this public key to encrypt the given plain text, but anybody cannot decrypt that message except the person to whom it is being sent. In this particular case, Ram is the person who is receiving the message. He can only decrypt the message with his private key. So in this particular algorithm, there are two different keys which are being used. One key is known as the public key, the other key is known as the private key. Similarly, in a computer network, there may be n number of persons. If a person wants to send an information to another person, for example, Krishnan is sending a message to Raman. Krishnan will be encrypting the plain text using the Raman's public key, and it goes to the other end, that is to Raman, where Raman will be decrypting the message with his private key. In this particular case, the advantage is the plain text is converted with the help of a key which is not used for decrypting the message. For example, or any intruder, if he reads the cipher text, if he knows the public key and if he knows the encryption algorithm, he cannot decipher or he cannot decrypt the original message, because this original message can be obtained only with the help of the private key, which is known only to the Raman. It cannot be obtained by anybody else except Raman. This is one advantage. Second usage of this particular algorithm is, in case of a secret key algorithm or symmetry key algorithm, the main difficulty is the distribution of the key, secret key, or maintenance of the key, that is to be maintained secret. But in this particular case, the key need not be distributed, because the key which is being used by the sender is different from the key which is being used by the receiver. And one more point here is, this is reversible. Suppose if you use the private key for encryption, you cannot decrypt it with the private key. You have to decrypt it with the public key. That means the process is reversible in the sense, you encrypt that information with the public key and decrypt the information with the private key if you want to provide confidentiality. Suppose if you want to encrypt it with the private key and if you want to decrypt with the public key, the application is different. For example, you are sending a document to another person. You want to know whether the document is coming from the original person or not. How can you identify the document is coming from the original person or not? Here is a very useful algorithm or very useful crypto system which is helping us in order to identify whether the original document is being sent by the person Raman or not. For example, you take this particular case where Raman is sending a message. Krishnan wants to know whether the message is coming from Ram. So what Raman will do, he will encrypt the message with the private key of Raman. So the Krishnan at the other end, he will decrypt the message with the public key of Raman, which clearly indicates that Raman only encrypted the message. At the other end, Krishnan will decrypt the message There is another application for this public key crypto system, that is, you consider the situation where the documents are sent from one end to another end, where the other end needs to check whether the document has been originally or whether the document has been sent from the intended sender. This is the situation. So in this particular situation, how the receiver knows whether the document is really sent from the intended sender. So this is where the public key crypto system comes for help. For example, if you send the plain text, encrypt the plain text with the help of the private key, and if you decrypt that message with the public key of that particular person, when you decrypt it properly, it clearly indicates that the message is coming only from Ram, because nobody else can have this private key of Ram. For example, Raman is sending a document to Krishnan. When Raman sends a document to Krishnan, there is a necessity to identify whether the document has been sent from Raman or not. So what Krishnan will do, he will try to identify whether the document is sent from Raman or not. How is it possible? It is possible with the help of the public key crypto system like this. Suppose if Raman is sending a document, what Raman will do is, he will encrypt the message with Raman's private key. So when it goes to the other end, Krishnan will be receiving the document. He will try to decrypt the message with the help of the public key of Raman. If it decrypts properly, that clearly indicates that the document has been sent by Raman. If it is not decrypted properly, it clearly indicates that the document is not sent by Raman, because the private key is in possession of only Raman. Nobody else can encrypt the message with the help of the Raman's private key. So in this particular situation, we can easily identify whether the document is originally sent from this end or not. In this session, we are going to see various techniques which are used to maintain confidentiality. Let us consider the case 1, where a message is sent from end A to end B. The message is supposed to be confidential. The confidential message should not be revealed to anyone else except the end user B. So in this particular case, if it is to be protected from any intruder, naturally we have to convert the original message so that the original message is not transmitted as it is in its original form, so that the intruder cannot read the message or intruder cannot use the message. This is the solution for the case 1. Let us see what are the techniques that are being used in order to convert the original message so that it is not readable or it is not usable by any intruder. Rather, it has to be used only by the end user B. So this process of conversion is called encryption. When it goes to the other end, we are using a technique called decryption, so that we will be getting back the original message. Before entering into the different techniques for encryption and decryption, let us see certain important terms. The message which is being sent is called as plain text. The message that is converted into a form after encryption is called ciphertext. The process of converting the plain text to ciphertext is called encryption, and the process of again getting back the original message from the ciphertext is called decryption. In this process, we will be using a combination of characters put together, which is called as a key. The plain text is the original message. Encryption is a process which is used to convert this plain text into a ciphertext. Decryption is a process which is used to get back the plain text from the ciphertext. In this process, a key is being used. Let us see these techniques one by one. For example, I am sending a message, network. This message is now called as plain text. This plain text has to be converted into a ciphertext using an algorithm or using a method. The algorithm or method is called encryption. Encryption algorithm. Using this encryption algorithm, this plain text has to be converted into a ciphertext. Here, there are two types of techniques which are being used in order to convert this plain text into ciphertext. You consider this example where this is the plain text, the original information is transformed into a form like this, where the technique which is being used here is rearrangement of the existing characters. So we are getting this ciphertext. So algorithm which is being used here is known as transposition. We can use another technique here in order to convert this original information into a ciphertext, that is called substitution. For example, we will substitute a character for n, let it be A. We will substitute a character for E, let it be C. We will substitute a character for T, let it be K. Let us substitute a character for W, let it be N. Similarly for other characters. Here in this particular example, character A is substituted for N, character C is substituted for E, character K is substituted for T, and so on. After encryption, the message which is being sent is A, C, K, N, M, J, and L. How to get back the original message? We have to substitute back the original characters. So that is what is called the decryption algorithm. Then we will get back the original message. The crypto system is broadly categorized into two types of crypto systems based on the key which is being used. The first is the private key crypto system, where only one key is used for encryption and the same key is used for decryption. The second one is the public key crypto system, where two keys are being used. One key is used for encryption, another key is used for decryption. Let us see how these two crypto systems are working. Before seeing how this private key crypto system functions, let us see some key terms. The original message is called plain text, and the method which is used for converting this plain text to ciphertext is called an encryption algorithm. A key is a combination of characters or combination of bits which is used along with the plain text in order to convert the plain text to a ciphertext. Ciphertext is the resultant message after encrypting the original plain text. Now let us see how private key crypto system functions. The plain text is converted using the key by means of this encryption algorithm. When it goes in the transmission media, it is not in a readable form. So any intruder, if he tries to reads the message, he has to know what the key is, but the key is kept secret. Unless otherwise the key is known, nobody can decrypt this message and get the plain text. If you want to get back the original message, then you have to use the same key and convert the ciphertext into plain text using this decryption algorithm. In this particular case, the key which is used for encrypting the message is used for decrypting the message. The advantage of this particular algorithm is you have to use only one key, and that key is distributed to the other end so that the plain text is encrypted using the same key in order to get the ciphertext. Similarly, the same key is used to convert the ciphertext into plain text. Let us now see how public key crypto system functions. Problem with the private key crypto system is the key distribution. As we all know, in a computer network there are n number of persons, n number of people communicating with another set of persons, where keeping this key secret as well as distributing the key is a issue. But in case of this public key crypto system, the key which is being used for encryption need not be used for decryption. This is the advantage of this particular public key crypto system. One more advantage here is, in case of public key crypto system, we can make use of the same algorithm for authentication purposes also. In case of public key crypto system, a key is used for encrypting the plain text and another key is used for decrypting the ciphertext to get back the plain text. Here, if anybody wants to read the message, or if any intruder reads the message, he cannot decipher the message with the help of the public key which is known. Rather, it is a different key which is used for decrypting the message. If, for example, Krishnan is sending a document to Raman, Krishnan will be encrypting the message with the help of the public key of Raman, so that nobody else except Raman can decrypt the message, because only Raman has the other part of the key which is called the private key. So when it goes to the other end, Raman will decrypt the message using his private key. So here in this case, if, for example, if Krishnan wants to send the message to Raman and Raman wants to know whether the message or the document is really coming from Krishnan, we have to use the same algorithm with a variation here. Krishnan is sending a message to Raman. Raman wants to identify whether the message is really coming from Krishnan. So what Krishnan will do, Krishnan will encrypt the message with the help of the private key. That is, this private key is the key of Krishnan. And Raman will decrypt the message with the help of the public key of Krishnan, which clearly indicates that nobody else except Krishnan is having the private key. Anybody else cannot encrypt the message. So when Raman decrypts the message, he clearly understands that the document is really coming from Krishnan. So this is another application where public key crypto system is being used. There are two types of techniques which are being used for converting the original message into ciphertext. Based on the way by which it is converted, we can classify them as substitution and transposition. For example, if the message is network, using substitution technique, network is converted into another form by substituting a character for every existing character in this particular message. Let N be replaced by B, E be replaced by C, T be replaced by D, and so on. This is the plain text and this is the ciphertext, and the ciphertext goes to the other end, where this has to be again converted back to the original text by replacing the original characters in the respective positions. Transposition is a technique where the existing characters are rearranged. For example, let us take the same network as the original message, where the characters which are existing in the original message are rearranged in such a way that we will get the cipher text like this. For example, K comes here, N goes here, T, E, O, W, R. Here if you look into the cipher text, the characters which are used in the cipher text is same as the characters which are being used in the plain text, but the only difference is the characters are jumbled or the characters are rearranged, so that any intruder cannot intercept. When he intercepts, intruder cannot read what the message is, or it is not in a readable form. So this is how transposition is applied. But in general, the standards which are widely used all over the world, they uses this substitution and transposition techniques combined together, so that it will be more efficient as well as more powerful. We have seen some general concepts involved in any crypto systems, but practically if you take any crypto system, they fall in one of these two categories, that is either a public key crypto system or a private key crypto system. There are other security threats which are to be handled. For example, suppose if you send a document, if